10 years ago, Kubernetes revolutionized our way of running workloads. Now it's reinventing itself again to adapt to new challenges. Static provisioning was an achievable luxury for traditional workloads, but it's grossly unaffordable for emerging AI and ML needs. To optimize spending and navigate global resource contention, more sophisticated, deeply dynamic scheduling is necessary. Let's travel from here up through all the layers of the stack, where myself, Corentin, our Google coworkers, and the whole community have been working to make dynamic workload scheduling more powerful than ever before. So let's start at the pod level. It used to be all about CPU and memory, which had been treated fungibly in the last decade. But today, workload authors know that hardware can make a big difference on how their workload performs. When it comes to hardware devices, there are a multitude of options. And all of these options come with trade-offs in the cloud environment, like cost, availability, or performance. Dynamic resource allocation is a new set of pod parameters that give workload authors the model to express sophisticated hardware requirements and preferences. It's now possible to give a very specialized pod just a small part of a machine that could be shared with other specialized pods, or on the flip side, you could give it exclusive access to all the GPUs on a node. The breadth and depth of attributes available to you now with DRA give you a totally new, unparalleled flexibility. Once you have defined a pod's resource claims, you can leave it to the system to satisfy it on the fly and pack your nodes as efficiently as it can.
With these fancy demands, node allocation has to follow through to provide the desired resources. But for the first time in a long time, big clouds don't feel so infinite anymore. Everyone is fighting for the popular card that just got wrecked. Just-in-time capacity tools like Carpenter or GKE custom compute classes are giving you the ability to define exactly what your priorities are, whether you can leverage a spot instance, prefer flexibility mixing reserved and on-demand compute, or as a last resort, fall back to a less powerful machine when running into capacity or quota issues. In compute classes, admins configure their preferences in any order, mixing machine shapes, hardware, or availability class. The cluster-autoscaler then dynamically provisions the right instance at the right moment, keeping the cost low while optimizing for the ability of compatible hardware. If you still can't get a node in the region where your cluster is, sometimes reaching a bit further is better than in a scheduled workload. We have the ability to zoom out and look at multiple regions for better availability. But it's often hard to know where specialized capacity is, and the static system is unlikely to be utilized well. Recent efforts in multicluster introduce new tools to help you target or expand to entirely other clusters. For training batches, multi-queue is one example where a workload would look for space in a fleet of clusters. We're also very excited to announce that Google is open sourcing a solution called Multicluster Orchestrator to achieve dynamic placement, especially of unique workloads like AI model servers. We just released a blog post talking more about it with a lot more info.
We've just scratched the surface of what's available today and the directions that Kubernetes is going. Myself, Corentin, all of our coworkers at Google, everybody in the Kubernetes community, everyone's working hard to give you the tools to level up scheduling for your workloads. This KubeCon is full of talks that will allow you to explore this new age of dynamic provisioning. And you can always come visit us at the Google booth and ask us more. We look forward to seeing you there, and thank you for having us.
Thank you.